Assalamu alaikum. Welcome everyone. I'm just trying to make sure that you're listening me clearly and you can see my screen, the screen of my laptop. Those who are listening to me, can you please confirm one of the attendees, please? Okay, thank you. So inshallah, we'll start the session in few minutes. As we have planned, we're supposed to start at 1:30. So we are almost close to that time. Okay, so I think we can start now. It's the scheduled time 1:30. In fact, 1:31 in my watch, and we are having around 42 attendees. Thanks for joining. Uh, those who have joined, I can see most of my beloved students from different courses, and we have Dr. Zainab also. And we hope that by the time we proceed, inshallah, a few more people will join. So, okay, let me start the recording also for my future reference. Someone has started recording already. Okay, good, no problem. Oh. Okay, so welcome everyone. We are going to start the webinar or seminar on power plant engineering fundamentals. Please feel free to tell me if you have any problem, any technical issue or something. Let me just see this one. Just got an email from stupid. Okay, Bismillah. So, as you know that the topic of today's webinar is power plant engineering fundamentals. So mainly we are going to talk about the power plant, and all of you know that the power plant is the place where we generate our electrical energy in bulk quantity. Okay, in the small quantities, there are some other places where you don't need to go till a power plant, of course. Okay, but if you want to generate the electrical energy in bulk quantity, and if you want to contribute in the national grid, so this must be coming from power plant. So here we are talking about the power plant and a bit detail of it, but we cannot cover a very detail of the topic, because you can see from the name that it's kind of an engineering, and there are different type of power plants with lots of in-depth ideas and knowledge, but we'll try to cover some very important fundamentals of the topic. So I'm presenting myself. I'm Dr. Muhammad Shoaib Shahriar. I'm a faculty member of our E department of University of Hafr Batin, and I'm working here as an associate professor. So let us first look at the power system. Okay, as an electrical engineering student, all of us more or less know that the power system actually, it consists of some components. Those who are here among the students and have completed 300 level courses, 360 and the other courses, they already know about it. The power system actually, this is the starting point actually, this is the starting point. And in the starting point, you can see like we have the power plant. So we generate the electrical energy over here in the power plant. And then we actually use a transformer to increase the voltage. Okay, so increase the voltage. And then we send this high voltage electrical energy or power through the transmission line. Okay, so this is our transmission line. So these transmission line are initially high voltage, but more it goes close to the load, because you see this is the load and this is our house. And here we are using our electrical energy over here. So more we go towards the path, you can see the level of voltage. This is become 25 kV. This has become 120 V. So the voltage will drop down. So to decrease the voltage level, we again need some transformer. We call them distribution transformer. But initially, when it was the case of rising the voltage, the transformers were transmission transformer. So in the distribution transformer, we step down the voltage. And finally, when we are close to our load, this is actually the service transformer, which converts the voltage and step down the voltage to a value which is usable for the consumer. Okay, so this is actually, this part is known as transmission part of the power system. This part is denoted as the distribution part of the power system. And over here we have the load. So if you talk about the power system, it consists of some components. One is the power plant. What we have inside the power plant, we have generator. So this generator generates actually electrical energy. Okay, then we use transformer. So if you just divide it into components, generator, we have transformer, we have transmission line, and when we come to the load, there are different type of loads, but one of the very important component of the load is motor. Okay, so you can say this number 4 and so on. We have different other things also, but these are the major components. Okay, so now if you look carefully, that in our curriculum, those who are senior student present in this session, they know that this about generator, about transmission line, and the transformer, motor, we have course EE360. Okay, we study them, all of these components or all of the electrical machines in E360 course. Before E360, in the course EE213 and EE211, we come to know that what are the type of electrical energy we have, whether this is DC or AC, whether this is single phase or three phase, who is better, which is having benefit, which doesn't have, some more benefits and so on. Okay, pros and cons. And then when we go to level 400 level in EE463, we talk about the power system analysis. So we do the analysis, how the power flows and what are the type of faults, what is the stability condition and so on. In EE465, we talk about how the power is transmitted and distributed. In EE466, we talk about how we can protect our power system from different type of faults and so on. Okay. But one of the major things or one of the major component actually, we don't study as a course is that what happens inside this power plant. Yes, we know that, there is a generator and we study this generator as a chapter of EE360, but a very, we have a very shallow idea about what happens in the power plant. Okay, so because this power plant, inside the power plant, there are different types and categories, and there are various ways of generating the electrical energy. So this is actually our focus today. We will focus over here inside this power plant, and we'll try to see what happens inside this power plant and what are the type of power plant and how it converts in something into electrical energy and so on. Okay, and what are the future aspects, and what is the current scenario and the future aspect in terms of Saudi Arabia, and finally we'll take some questions and so on. So you can consider this slide as an intro. So proceed further, as because I have already mentioned that inside the power plant we have a generator. So first of all, we need to know the basic of the generator very quickly. Okay, because this webinar is for, just let me get back and see, is everything going well? Please feel free to write comments or put any question if you have in your mind, or if you have any technical issue, for example, I got disconnected or something, please speak up so that we can solve our problem. Thank you. So let me proceed. So as I was saying that the generators are inside the power plant. So I will very quickly talk about the generator that will help us to understand the power plants. Okay, so the generator, we all of us know that it is a machine which converts mechanical energy into electrical energy. So as an input, we give mechanical energy or mechanical input. So it's kind of torque and omega is rotation. So if we provide this input to the machine, it will give us the electrical output as voltage and current. Okay, so how it happens actually? So we'll know about that. But before that, there are different type of generators, of course, based on the output pattern we get. It can be DC. Okay, so that means, the voltage level is always same. It may be AC. That means, the voltage, it fluctuates. Okay, it may be single phase or three phase. So maybe it is having just only one phase, or maybe it is having multiple phases. Okay, so maybe it is having multiple phases. So they are having some phase shift and so on. Okay, so these are the types. And for the power system, which one we use actually? Do we use DC? No. AC single phase? No. Actually, we use three-phase AC generator. Okay, and why this is actually, we discussed this in a course EE360 in chapter 1 in detail, but it has some advantages, of course, to use three-phase AC. It provides us high, the constant average power always, and we can transmit high power throughout a long distance, and we can, there are more flexibilities in the three-phase power system. So that's why the generators should be three-phase also. And another name of this type of three-phase AC generators are synchronous generator, or sometimes we call it alternator. Okay, so how this electrical energy gets generated? So what is the theory behind it? The theory behind it is described by Mr. Faraday in his law of electromagnetic induction. It says that the current is induced. Of course, we know that the current is induced whenever there is a potential difference, plus minus V. Okay, so that means V or E, whatever you see, say. So this E is a voltage. So this voltage gets induced when it is induced when you will have a conductor inside a magnetic field. Okay, so for example, you have a magnetic field, North Pole and South Pole. So for example, this is a magnetic field. The flux is flowing over here. So if you put a conductor inside this magnetic field, for example, this is the conductor you have put, okay, a conductor. So this conductor you put, and what you have done, you have started rotating because it needs a relative motion between the conductor and the magnetic field. So if there is a relative motion, so you can see this flux is actually the magnetic field that is denoting the field. Okay, and this d by dt is denoting that there is a motion because it's changing with respect to time, isn't it? And this n is the number of turn. So because this conductor is actually a coil. Okay, this conductor is actually a coil. So more coil you provide, more number of turns you provide, more voltage it will get generated. So this voltage is actually the voltage which is the output of your generator or of our generator. So this is actually the theory behind it. So we need two things. One is a magnetic field, and the second one, we need a conductor. And of course, number three is a relative motion. So this conductor needs to be rotated, okay, or it needs to move. Now, based on this idea, if you look at DC generator, so whatever I have explained in the previous example or the previous slide, just have a look, the same figure I have drawn over here. So this is the principle of DC generator. You have a North Pole and South Pole, and you have put a coil or a conductor, this one, and this conductor is rotating. So this rotating means it is getting actually mechanical input. So what you are getting as an output, you are getting as an output voltage. So this is actually your electrical output. So then you can use a load, any load you want to, light, fan, or like whatever load we use in our home. So you can now connect across this output terminal. Okay, this is the principle of DC generator. Now, if you see here, there are two components. One is actually the one who is moving inside. Okay, so that means this one, we call this one armature. This one is moving actually. Can you see? Because this one is moving, this armature coil, this one is moving. And the one who moves or who rotates, we call it rotor. Okay. And the second one is this magnetic field, who generates this magnetic field. Okay. This one is not moving. This North Pole and South Pole, this is not moving. If both are moving, there will be no relative motion. So one needs to move, another needs to be stationary. So because this is stationary, we call it a stator. So actually, the generator has these two components, stator and rotor. Okay. Now, this was the case for DC generator, that armature, who is actually the conductor, was rotating, but a stator or the magnetic field, it was not rotating. So if you think about the AC generator now, okay, now let's focus on the AC generator. So the one I have showed, this is DC. In AC generator, exactly the opposite thing happens. Here, who rotates? Actually, the field rotates. You see, the field, look here, this field is actually this north and this south. So this is actually rotating. Okay, so the field is rotating. So that means, it is connected with rotor, and the conductor who is here, okay, it is not rotating. This one is fixed. Okay, so that means here it is connected with the stator. So you can look at this picture also. You see this North Pole and South Pole and North Pole and South Pole. So this magnetic field is rotating, and the coil who is actually containing the armature conductor is not rotating. So, but still it will generate the electrical energy, isn't it? Because what? Because of what? Because still there is a relative motion. Because we want relative motion, and we know that the relative motion phi and the differentiation of that d by dt, d phi by dt is still present here. So we don't bother who is rotating and who is fixed. So this is actually the AC generator or alternator. So now, up to now, I hope it is clear to the audience. But maybe you're thinking, what's going on? We have come for listening about power plants, and he's talking about the electrical machines, the generator and flux and this and that. So actually, they are very relatable, because from the next slide, you will start understanding that how this is very much linked with the basic principle or the basic fundamentals of the power plant. Because now you know that there is something called rotor, which needs to be rotated. Okay, this is one thing. Second thing is that these two questions should come into your mind now. So who rotates this rotor? Because rotor is something in the power plant, they are of very big size, and you need to rotate that. So it's not possible for a human or for someone to rotate this one continuously. Okay, so it needs to get energy from somewhere. Okay, so these two questions, if you know the answer, you will now start into the idea of power plant engineering. Okay, so who rotates the rotor? Turbine rotates the rotor. So this is the third term after stator and rotor. So you have to understand that turbine is someone who rotates, who is connected with the rotor, and whenever the turbine moves, it rotates actually the rotor coil. So, and where it gets energy from? It gets energy from nature. So in nature, we have energy in different forms, sometimes as heat, sometimes at wind speed, sometimes inside coal, inside oil, gas, and so on. Okay, so this nature actually contains energy in different forms. So we use this energy, and we rotate the turbine that rotates the rotor, and thus actually we run our generators. Okay, so what are the type of what are the type of energy we have in the in our nature? Actually, you can divide it into two main categories. First one is the fossil fuels. So the one which are available in fixed quantity in the world, which are non-renewable. Once you use it, you cannot reuse it again. So we call it not renewable. And some are renewable, so which are present in the world in unknown amount of quantity, and more you can use and keep using and keep using, uh, and it will not be finished. Okay, uh, till the end of the lifetime of this world. So let us look at so now officially or formally we are proceeding towards the power plants. But before that, let us have a look on what are the fossil fuels we have. So the coal is one of the fossil fuels. Okay, so I think all of you know about it. Like the coals are very commonly used uh, in making barbecues, okay, in our homes, or when we go for party or in tents. So the coals are used. So oil, yeah, the one which has made many countries rich, the oil resource. The natural gas, this is a similar thing, okay. Maybe kerosene, this is a kind of oil also. propane, this is a form of gas. Okay, and so on. There are some other types also. And what are the renewable energy sources? Hydroelectric. So it is actually the pressure of water. Wave energy. So this is the wave of the water flow or something. Okay, so tidal energy. This is also inside the water. If you have high speed of tide, so that will generate some energy. Solar energy, which comes from the sun. Biomass, by burning the usable non-carbon materials. Okay, so we have the biomass energy. Geothermal, which is actually a form of energy or heat energy, which is present under the ground, because you know that more deeper you go under the ground, there are some plates which are having very high temperature. So this is geothermal energy. And finally, the wind energy. Okay, there are some other forms also, but these are some basic, okay, or main parts of renewable energy, wind energy. Okay, so now after knowing this different type of energy resources, now we can know that what is a power plant. So the power plant, as you know, that this is a place where we generate the electrical energy. So it is actually a conversion of energy to electrical form from another form. Okay. Usually the power plants are away from the locality because it has uh, some pollution effect, because it needs a large amount of space, and it creates hamper in livelihood. So that's why usually we build our power plants away from the locality. Okay, and just at the adjacent of the power plant, we have the transformer, high voltage transformer, as I have showed in the first slide, that you need to step up the voltage. So that's why this is also the starting point of the power transmission. Okay, and the power plant's type. So what are the type of the power plant? So that depends upon actually the fuel you used, to run the power plant. Okay, so based on that, so before we enter into different type of power plants, let's have a beautiful view of one of the power plants. Okay, so maybe have been taken by any drone or something, but it's looking good. So these are different type of power plants. We'll talk about them a bit detail in the new coming slides, but these are the types of the names. You can see nuclear power plants. Of course, you understand it uses the property of nuclear something. Okay, natural gas power plant, coal power plant, geothermal. Okay, hydroelectric, wind power plant, and solar power plant. Concentrating solar. This is also a kind of solar power plant. Tidal power plant. Among them, some of them are very widely used. Okay, some of them are very widely used, and some of them are not very widely used in most of the countries. Okay, but under research, or the countries are trying to increase the capacity and doing some more research in progress. Okay, so these are the different type of power plants. So we will start with the thermal power plant actually. Okay, or this is also known as steam power plant, and this is actually the traditional one. Okay, this is the mostly used, and which this type of power plants generate most amount of electrical energy in the world. Okay, and in this type of power plant, you can understand from the name thermal, this word means that this is related with temperature, right? So it is related with temperature. So, and you can understand that what is the use of the temperature? So the use of the temperature is to generate the steam. What is steam? Steam is actually when you boil any water. Okay, so that produces the steam. So actually this is the gaseous form. This is the gaseous form of water. Okay, so the gas version of water. This is the steam. So actually we boil water it creates superheated, very high temperature and high pressure steam. Okay, actually that one flows through the turbine and that powers the turbine. So thus the turbine rotates, and as we have learned from before, that whenever turbine rotates, this turbine is connected with our rotor. This rotor also rotates. Whenever this rotor rotates, actually it cuts the North Pole and South Pole magnetic field. Okay, so and thus we generate the electrical energy. So this turbine is having actually the energy from somewhere. Okay, where it is getting the energy from? It is getting the energy from burning the fossil fuels. So coal or gas or oil, they are mostly used. Okay, so they produce the steam. So actually we give these fossil fuels as the input over here. Okay, and burn them to generate the boiled water, and that generates actually high temperature and high pressure steam. This steam flows through the turbine, and this turbine actually rotates the rotor. So this is in short the idea. Okay, what is the, I will show you the flow diagram and detail of it. So what is the positive of it? This is very reliable. Why reliable? Because you don't have, there is no uncertainty uh, in terms of having coal, gas or oil. So if you have coal in your hand, gas or oil in your hand in the reservoir, you can generate electrical energy. So you don't have to the uncertainty is less actually. So like the way we have the uncertainty for sunlight for the solar system. Sometimes some days are sunny, some days are cloudy. Okay, so the solar power plants are unpredictable. So they are not fully reliable. But if you talk about this type of thermal power plant, they are very reliable. But it has some negatives also. They produce greenhouse gases. So these greenhouse gas emission is actually a big concern for this type of power plants, because I think most of you know that there are some gases like carbon dioxide and methane, and then some other type of gases. These greenhouse gases actually they they can create harm in the ozone layer we have. Okay, and which actually allows the sunlight or the heat to come directly towards the earth, and that causes the global warming. Okay, so because of this burning fossil fuels, we have we actually emit a large amount of greenhouse gas in the nature. Okay, so this actually creates environmental problems. Okay, environmental issues. So this is actually the biggest concern about this type of thermal power plant. But it's still, this is the mostly used power plants in the world currently, and the traditional one. Okay, but as you know that they require a large amount of water for cooling, because whenever you generate this superheated high temperature water, you need to cool that down. So you need a large amount of water for cooling, and also it affects the environment, which I have already mentioned, and also local ecosystem also, because like whenever you produce this type of gas, and when you produce this amount of gas in a particular area, it creates the problem in the ecosystem, the local ecosystem surrounding the power plant. So if you look at the flow diagram of a picture of a steam power plant, which is the coal fired. Okay, so how it looks like. So you see this coal, this is actually the reservoir of the coal. So you can see like we have gathered lots of coals, and we are providing these coals in a place which is known as a boiler, okay, or a furnace. This boiler is already having water, and this water is supplied. Some of the water is supplied. You can see over, underground we have a river or a water reservoir. So this water reservoir, actually there is a connection. So we provide the water inside the boiler, and we actually generate, we burn this water, which produces the steam. So if you see over here, like the water is coming through this channel, this blue line. So more it goes through, the color is changing. So actually at this point, it is actually converted into steam. Okay, converted into steam. So this steam is then passed through it, make it high pressure. And this high pressure steam is flown in this turbine. So look at this turbine. This is actually our turbine. The turbines are actually blades. So when you uh, provide high pressure steam through these turbine blades, these start to rotate. Okay, this start to rotate. So this rotation actually is connected with your generator. So this is your generator. And as you have already listened from me, that this generator over here, you have your rotor. So this generator then, is connected with your transformer. And finally, this transformer, actually, it takes it to the transmission line and so on. Okay, so this is actually the way how the coal is used to convert this energy inside the coal into electrical energy. But actually, we use a cycle because the water, which is, flowing here in a high pressure, this is also having high temperature. This high temperature or, hot water is then passed through a process over here. This is known as condensation. Condensation means cooling down. Okay, so this cooling down of water, this cold water or cold water is then again sent back to the boiler for reuse. And to keep balancing of the water level, we can use this river as a reservoir. Okay, but you can see that the heat or the fuel which is created from the boiler is coming out through this chimney. Okay, so this is actually the output which is generating greenhouse gas. Okay, so this is actually the structure of a steam power plant. Now, instead of coal, if you use oil, this is the same thing. If you use natural gas, this will have the same structure. So whether you use natural gas or oil or coal, but the basic idea will be same. So starting from this point and onwards, that will be exactly same. Only the input is different. Okay, so this is actually the steam power plant, and I hope that you got an idea about it. Okay, so this is actually the breakdown. You can see like the coal is supplied, then the boiler, the water will be provided inside the boiler. This is the boiler we have, and water is coming into the boiler. It is heated up and converted into steam. Okay, this steam is high pressure steam is provided to the blades of the turbine. This turbine start to rotate. That will rotate, or that will uh, turn on the generator, and this will be connected with the further level. So this is actually the zoomed version of the same figure, but a more breakdown version. Okay, so uh, if you look here in an extended version, sorry. So actually the full screen mode was not showing me the full. Okay, so there is something in the wasted energy. Yes. Okay, so well, I will take you all your questions. So if you have any question in mind, uh, while I'm giving the presentation, you can put that in the comment section. I will respond to that at last, inshallah. Okay, so proceed further. Okay, so this is actually another version of the steam power plant, but I will not, there is no need to talk more details. So you can see this is a ship which actually, has brought the coal, and this coal is coming over here. And by the way, this, how can I, this, sorry, this taskbar is not disappearing. So actually it is taking, okay, okay. So it has removed. Okay. So, I was not seeing the bottom part of the screen, so I was a bit confused. So you see over here, so this ship has brought the coal, and this coal is unloaded over here. And this is the coal yard. And this coal, raw coal, we cannot give directly to the boiler. So it needs to go through some process. Okay. So process means, we need to do some purification and so on. And after the purification, it goes to this boiler. So this is the fire to make it high, hot water or steam. This steam is then, transferred into the turbine blades we have. So this is the turbine unit over here. So it has some different parts or units also. This is the condensation process we have. And, to make up, sometimes we need to provide some makeup water. And the wasted gas is then, shifted from this part. And some of the gas, maybe they have been converted into ash, which has been taken by this lorry to some disposal area. The remaining gas, we also try to do some filtering and purification process, but the remaining is sent to the air. So still it has some greenhouse gases. Okay. And here is the generator we have. And this is the chimney, which actually, this one is actually the one which all, which is having only the, water vapor. Okay. It is more white. Okay. And the color of this one is more dark, because, this is coming from the furnace or the boiler. This is coming because, this is connected with the condensation. So whenever you do the condensation, some part of that will be converted into vapor. So that vapor will be also released to the air. So this is actually this is not harming for the environment. Okay. This is harming for the environment. Okay. And this generator is now converting into electrical energy. Okay. So this is actually the steam power plant we had to discuss. Now, the next one we have is the nuclear power plant. So this is also a thermal power plant. Okay. So here, actually, the basic idea is same, is that we convert the water into high temperature, high pressure steam, and that steam rotates the turbine. But the way of generating that steam, or the way of generating the heat, is different. Before, in the steam power plant, this type of steam power plants, okay, which are, the coal or oil or natural gas, we use these resources, which are the fossil fuels, to generate the heat. Over here, in the nuclear power plants, we use nuclear fission. We use nuclear fission to generate the heat. This is the only difference. Remaining are same. Okay. So I hope you have heard the name of fission and fusion, two kind of, chemical reaction which happens for the nuclear particles or the component. Okay. Uranium oxide is mostly used in the nuclear power plants. So the fission of the new uranium oxide is used and to generate the heat. How it works? Actually, in fission, we hit the uranium oxide atom by some neutron particles in high speed. And whenever we hit that one, the atom, it splits. And whenever it splits in a surrounded area or in a closed area, it starts to, hit with each other, and, it kind of generate a chain reaction. Okay. So in this process, a significant energy is released from the atoms. Okay, and can you imagine that how much is the energy, release energy? It is so high that it creates up to 320 degrees Celsius of temperature, where you know that the boiling point of water is 100 degrees Celsius. This is the boiling point of water. Okay, so this is the boiling point of water. So you can understand that if this fission process generates up to 320 degrees Celsius of temperature, so it is more than enough to boil your water and produces and to produce this steam. Okay, this steam is actually then made into high pressure and it will operate the turbine. Okay, so this is actually the picture of one of the nuclear power plant. You can see over here, and like you can understand that how big it is by looking at the picture of this car. You see, there are some cars parked over here to give us an idea that how big a nuclear power plant or any power plant is. Okay, so if you look at the car, you can just get some idea that how big they are. Okay, so in this type of nuclear power plants, as because we do not burn any fossil fuel, as because we do not burn any coal or natural gas or oil, so the carbon emission or uh, the emission of the greenhouse gas are very low. Okay, but there is a high risk because you are dealing with nuclear material, so they are highly radioactive and they are very dangerous for human if they are exposed in environment. Okay, and it creates radioactive waste, so you have to be very careful in dealing with the radioactive waste which is coming out of this type of power plants. And you need to be also this type of power plants are demanding very high expense in establishment. Okay, so yeah, these are some very key points of nuclear power plants. I have tried to make it very straightforward and simple, not very detailed, but trying to give you a picture, a good picture about the power plant is. So the biggest power plant which is run by nuclear fission is in Japan. Okay, which is having 7,000, almost close to 8,000 megawatt capacity. Okay, which is a very big capacity of electrical energy, you can understand. Okay, so this is actually the picture. So as you have understood already, the steam power plant or thermal power plant, this is supposed to be very clear to you. Okay, so you see, you have a nuclear reactor over here. This is the core nuclear reactor. Okay, and it has these rods. Can you see the control rods? Inside these control rods over here, you have the uranium oxide, UO2. Okay, and actually inside here, they are bombarded inside by the neutron, and you control that, and it generates the heat, high heat, and that heat is actually passed through here. Okay, and whenever the heat passes through this channel or this chamber, and we flow some water through this water pump, where the water is coming, from any lake or river. You see, this is the water input. Okay, water intake. So this water intake is coming, and a part of it is going to this part. Okay, and as because a high temperature is generated over here, this water is now converted into steam. Okay, this is the steam, and this steam, as because this is in high pressure, we flow this stream through this turbine, and the remaining story is known to you. So whenever this turbine rotates, it is connected with the generator. This generator converts this rotation into electrical energy, and we give it to transmission line. Okay, now the loop will continue because the same idea is that we also have the process of condensation, because the hot water now has been passed through it, which has been hot steam, and then it converted into again water, cold water in condensation. And that water is also this condenser, it again passes through the water pump and has given to this So in steam power plant or in fossil fuel power plant, we were calling this one, what was the name of that? Can you remember? The name of that was boiler, isn't it? So instead of boiler, you are having here nuclear reactor. So this is the only difference. Okay, this is the only difference. The remaining things are same. Okay, and this is the place where you emit the non-radioactive water vapor. Okay, so this is actually the nuclear power plant and the basic of it. I hope it is clear to the listeners and the viewers. Okay, so the third type of power plant, we proceed further, is hydroelectric power plant. Okay, so you can understand from the name, hydro is something which is related with water, isn't it? So water, we use the kinetic energy. We use the kinetic energy which is present inside water to generate the electrical energy. Okay. Now, maybe you are thinking, inside water, where we have the kinetic energy. Actually, we have. If you keep the water in a proper way, for example, you have two container, okay, or two glass of same size. It's not exactly same size, but think, assume that they are of same size. Okay, so this is container A and this is container B. Now what you have done, you have filled this container A up to here. Okay, and you fill this container B up to here. Now, if you put a tap over here, okay, an output channel, and you put an output channel over here to allow the water to come out, what do you think? Which, no, which container will have high pressure of water? Of course, this A, right? Container number A. Why? Because of this height. You see the height of container A, H1, is higher than the height of the container 2, which is H2. And this height is actually directly related with the energy, kinetic energy formula, which is H rho G. We all studied in the physics course. Okay, so this property of water is used in the hydroelectric power plant. Okay, to convert this kinetic energy into electrical energy. So idea is very simple, but if you want to use it. So this is very efficient and environment friendly because we are not burning anything. We are not burning coal or fossil fuel or anything, and zero greenhouse gas emission. Excellent one. Okay, because because of not burning fossil fuel, of course. And but you need to construct some dams because you need to increase the level of water. You have to put the water in a closed place where the level of water needs to rise up. Okay, so you have to use the height of the water. More height you produce, more power it can generate. Okay, so if you want to construct a dam, it may disrupt the ecosystem. And sometimes, in order to make this water reserve, what we do, actually, we connect the river. So we actually connect a river or a channel of the river. We make a channel of the river to make this dam. Okay, so it may affect the wildlife and habitats. So if you look at the basic structure now, so this is actually the reservoir where we have water. Now this water is, stopped by, the dam. So, and we control the flow of water by a gate. We call it sluice gate. Okay. Someone has turned on the microphone, please. If you know who it is. Thank you. So, okay. So this flow of water is actually it goes this way. So whenever it comes from this level of height, okay, this level of height. So of course you understand that it will generate whenever it comes down, it will generate a high pressure. Okay, and that pressure is used to rotate the blade of the turbine. This is very simple. You don't need to use any boiler or condenser or this channel, that channel, and so on. Okay, this, if you look carefully, this is very simple. Okay, so this high pressure of water is flowing through the turbine blades. So these turbine blades start to rotate now. This rotation is used for the generator's rotor to convert into electrical energy. So simple and straightforward. Okay, so but you need to use, and the remaining part will go to this tailwater part, and this tailwater sometimes they are given to used for some irrigation. Okay, sometimes they are used for some other purposes. Sometimes there is a channel to return back to the original reservoir. Okay, so this is actually the idea of the hydroelectric power plant. Okay, so again I am okay. So I hope it is clear. So the biggest hydroelectric power plant is in Hubei province, central China. Okay, this is the largest hydroelectric power plant, and with more than 22,000 megawatt capacity. Okay, this is known as Three Georges Dam in central China. Uh, and you can see this is a hilly area, because you need to have the water in a very high level. Okay, so the longitude of the river or the dam, it needs to be high, so that you have that kinetic energy. And these are the gates. Actually, whenever you open the gates, the water passes through it in very high speed. Okay, so this is actually the picture of the hydroelectric power plant. And in my country, in Bangladesh, we have one hydroelectric power plant it is known as Kaptai power plant. The capacity is, as far as I remember, 200 or 300 megawatt, not very big. Uh, but no, sorry, I think around 600 megawatt, as per I remember. Okay, so and Saudi Arabia now, they are planning for some hydroelectric power plants. But as for my research, there is no direct hydroelectric power plant till now in operation. Okay, so number 4 is actually solar power plant. So this one we have heard the name a lot. Okay, and we know that solar power plant uses the energy from the sun. Okay, so this is one of the cleanest and the most plentiful renewable energy sources, because it uses the sun. Okay, and we know that the sun, it is the source of very high temperature, and if you can use the sun to generate our to convert that into electrical energy, that will be a very good option. Someone wants to join our session. It's not in my home, somewhere else. Can you please, I don't know who is this, turn off the microphone. Okay, so okay, I think someone by mistake turned on the microphone. Okay, so this is the solar power plant. As I have already mentioned about it, that it uses the energy of the sun. So actually in the solar power plant, what we have? We have actually PV cells. I think most of you have heard the name of PV cells, photovoltaic cells, okay, or the panels. This is one way that these PV panels directly convert the heat energy into electrical energy. Okay, another way, this is way number 1. The second way is that we can use concentrated solar power system. So this concentrated solar power system is little different. I will talk about that, in the coming slide. So this type of power plant, a very important and a good use of the solar power plant is that you can use them in wide range of scale. So it doesn't matter that what amount of electrical energy you want to generate. Maybe you can install that in your rooftop. Okay, or maybe you can use that in the power plants also. So that means in low scale or high scale, in any scale, you can generate the electrical energy. But think about the other type of power plants, the hydro, the fossil fuel, the nuclear power plants. What do you think that can you make all this structure and all these big constructions to generate a very low amount of electrical energy? You cannot, right? So this type of power plants, when you take a project, then they're supposed to be a very big project with lots of planning and protection mechanism and everything. Okay, but the solar power plant is kind of very easy to use. You can use in any scale. Okay, you can just buy a solar panel, put it on your rooftop or anywhere. Okay, in your home, in your office, exposed to the sun, of course, and you can take the advantage from it. Okay, and they are zero greenhouse gas emission, and that's why this is actually the booming topic of research in the current world for a better future. Okay, now what is the basic way of working? It uses the solar panels. Sometimes we call it PV panels. What is the full form of PV? Photovoltaic. Okay, these photovoltaic panels are made of small units, which are made of, again, semiconductor material. Now, this semiconductor material you studied in electronics course EE 203, and you know that this semiconductor material, they are having some the N channel, P channel, some doping holes, and so on. Okay, so the idea is that whenever the sunlight is exposed on the PV, it releases the free electron. Okay, so whenever the surface of the PV cell gets heated, okay, it releases what? The free electron in the PV panel. So this free electron is actually in the form of DC. So directly we get the electricity supply. So you don't need to convert it. You don't need any rotor to rotate, any stator, any field, any armature or anything, nuclear reactor, nothing. You just need a solar panel. Okay, this solar panel, the sun is over your head. So this sunlight, it comes, and based on the property of it, actually it is having two layers. So the top layer is heavily doped, the doping is high. The bottom layer, which is more thick, is lightly doped. So in between, actually you have a depletion region over here. So whenever the sunlight comes and hits this heavily doped region, actually the electron electron in this depletion region, it actually attracted in this above heavily doped region, and that actually start flowing the free electron, and this flowing of free electron in the form of DC. Simple. Okay, so this is very straightforward. So this DC type cannot be used in the national grid or the power grid, because already your power grid is 3-phase AC, isn't it? So what you have to do, you need to have an inverter. So to convert from DC to AC, remember. Okay, so this conversion from DC to AC is needed if you want to use it as as in the national grid or in the power system of the country. Okay, so this is the idea. So the largest power plant, which is solar based power plant, is in India. So it is of 56 square kilometer area currently installed, and this is having 2245 megawatt capacity. But some other countries are making some very even larger power plants nowadays. even in Saudi Arabia. I will show you at last. Okay, but which are not being under operation. So they are under construction. Okay, some of them at very big size. So this is actually the basic idea of a solar power system, okay, or solar power plant, you can say. So the sunlight is coming on the PV arrays. So it is exposed on the light and it is converting into DC. This DC is used inverter. Okay. This inverter, of course, it converts from DC to AC. And this AC is provided to the transformer for a step up or down. Then it is given to the AC grid system. And this is our transmission lines. And this is our load. Okay. And also another important thing is that the DC energy can be stored and as battery backup. So you can connect the DC energy or the DC power. You can store that inside some battery packs. Okay, so this is a very good opportunity that you can store your electrical energy in this energy units. So I hope this is clear to the listeners. This is another form of using the sunlight. This is another type of solar power plant, but this is not the photovoltaic solar power plant. Rather, this type of power plants are known as solar thermal power plant. Okay, so from the name, maybe you have understood what it is. Solar is sun, thermal is heat. So we are using actually the heat of the sun to produce actually steam. Look at it. They are actually the steam generator. Remember the steam generator we used in type 1 and type 2, fossil fuel, steam generator, nuclear. Okay, the same type of steam generators are used over here. How? Look at it. This is your sun. Okay, so we use some solar panels. Look at the solar panels over here. So all these solar panels are actually having the sunlight. Okay, the sunlight is coming on the solar panels, but they are placed in such a way that they are all reflecting this solar light to a particular point, a receiver. And as you know that the sunlight is very hot, and whenever you are receiving all these sunlights as a reflection, this receiver actually is made in a special way that it can store, it contains the heat, and this heat is actually, you can store this thermal energy storage tank. Even you can store this thermal energy. And whenever you supply the water, you see this is actually the water supply. So when you supply the water through this one, this is blue color. That means normal water. But when it comes out from the receiver, because this is very hot, this has become steam. You understand? So this steam is then passed through the steam turbine. So this is the generator. It means that it has a turbine. You see, this is a turbine over here. This turbine is actually now rotating this steam. So this steam generator is converting into steam over here because this is hot water. This hot water is more, this steam generator, it make it high pressure and high temperature also. And also this one is passed through the turbine. This turbine is now rotating. This rotation is now converting into generator. Okay, for electrical energy. So this is actually the idea. So here we are using the sunlight to convert the heat of the sun to boil the water and make the steam. That steam is converted into high pressure steam, passed through the turbine, rotate it, and thus rotate the rotor and convert the electrical energy. So this is actually solar thermal power plant. I hope it is clear. This is the picture of a solar thermal power plant, a very big one. I think where it is, I forgot to put the name. I forgot which country is this, but some countries, they have really big solar thermal power plants. So you can see that lots of solar panels are placed, but they are placed in a way that they are all reflecting to this point. Okay, same here. Okay, So this is actually the solar thermal power plant. Okay. So I will just talk about one or two types more very quickly. This is wind power plant. This is another type of renewable energy source. This is one of the very fastest growing sources, and it uses the kinetic energy of the wind. This is simple, but they are intermittent. Why? Because they requires backup or storage, because the wind speed is not always same. So they directly use the wind speed and convert it into electrical energy. That's it. So inside each wind panel, okay, inside in each this wind turbine, so the mechanism is there. Okay, so just have a look on a wind turbine, how it looks like. So just have a look. It is having actually two part. One part is its structure. On it, inside it, you have sometimes you have ladder. So if you want to go up, okay, you can take this ladder. This is the tower, and you have the cable. This cable is, look at this cable. This cable is coming, and it is connecting with the transformer station. So this is your transformer. Okay. So what is actually happening over here? You are getting wind. You are getting wind in this rotor blade. So whenever the wind hits this rotor blade are made of such a structure, they start to rotate. Okay, they start to rotate. And this rotor, you can control the pitch, you can control the speed. There is a brake, there is a generator over here. So this, whenever you are this one is rotating, this is kind of a turbine. So you have a gearbox, you have measuring instrument, position light, position sensor. So maybe you can also control the position. So sometimes it is rotated in this direction, sometimes it is rotated in that direction, sometimes in this direction, and so on. Okay, based on the direction of the wind speed. So actually inside you have the generator. That generator generates the electrical energy. That electrical energy is actually coming through this channel. So this is actually your electrical energy. This is your electrical energy. So whenever this electrical energy is coming to this transformer, and then actually you are converting and sending it to the load end. Okay, so this is actually the wind type. So they can be of two types. One is onshore. So this onshore means that they are on ground. So you see like this onshore station, and the station pit and everything. And some of them are offshore. Offshore means they are not on ground. Not on ground means they are of course connected on ground, but some of them are also of the type of floating. Okay, there are some floating wind power plants also. Okay, because what is the reason? Because there are some places in the sea or river where the wind speed is very high. So before establishing the wind power plant, you need to do the analysis for a long period of time, over a few years, to understand that which area is more suitable, where you have the most high amount of wind energy. So as because the wind, you understand that to get the maximum benefit, the wind which supposed to hit these blades shouldn't be disturbed by any obstacle. So that means you cannot put these type of wind stations near the locality or near the city where the people live, where there are buildings or trees or this and that. Okay, so that's why it is a good idea that you put the wind stations offshore. That means in the water. Water means maybe in the sea, not in the middle, some part of the sea, sometimes inside a river, or somewhere where the surrounded area is not having any obstacle. So based on that, you have onshore and offshore. Okay, so largest wind farm is also in China. Okay, Gansu, China. Is just have a look. More than 10 gigawatt capacity, and they are also increasing the capacity. And as far I heard, as far I've read in the article, that it will reach up to 20 gigawatt of capacity. This is huge. So you can understand from that. Okay, so the last type of the power plant I will talk about is the biomass. Biomass is nothing but a fuel, but this is not a natural fuel. This is an organic fuel, organic material. It is made of wood, agricultural residual, municipal solid waste, and this type of things. So which are the waste of from the society, from our usage. Okay, so you use them, you burn them, okay, to generate the heat, and you produce the steam that powers the turbine. So this is actually similar idea of the steam power plant, but here you are not burning fossil fuels. Rather, you are using or burning the biomass. Okay, so these are the biomass power plant. So it has lower emission fossil fuel. If you use the organic wastage and if you use them properly, the carbon emission or the greenhouse gas emission will be also low. And the largest biomass power plant is in UK, 740 megawatt capacity. So this is the picture of that. And also you can see that just look, this is a car. Believe me, believe it or not, this is the car. And also you can see this is a big truck. So you can understand that how big a power plant is. Okay, so that's why sometimes I say in my class, the lecture, that if you find any opportunity to visit a power plant, uh, please try to visit. Okay, see it. That will open a new window in front of your eyes, that what's happening. Inside the power plant, that's a different world. Okay, so this is the flow of the biogas power plant. You see, like you are receiving conveyor, you are giving the biogas material or the what type of fuel you have, and they are grinded actually, and then they are put somewhere, the fuel storage, and they are put inside a boiler, and you hit that one, and that boiler actually it converts it into steam. That steam is produced over here. This is water and this is steam gas. That one actually, this is your turbine T, and this is your generator. Okay, and it has some wastage. That wastage is actually come through it. This some of them are in the form of gas. Some of them are in the form of solid. So if this is solid, you take your different ash pits and take them away and disposal. Sorry. So disposal. Okay, and this gas is emitted in the air. Okay, so this is actually different type of power plants, and there are some more types actually. Okay, but of course I cannot make it very lengthy to keep your concentration. So, but these are the basic and the main power plants which are used in the current world to generate the electrical energy. So more or less, you can divide into two parts. Some are using actually the steam generation, and this high pressure steam is converted into is sent to the turbine to rotate the rotor. Okay, another type is actually the green energy, which is, you can say, using the sunlight or using the wind energy. So which where you don't need to generate any steam, and they can be converted into electrical energy directly. Okay, so over here I will just give you a very quick idea about the power plants of Saudi Arabia. As far I have seen, searched in online, you can also search. Around 89 utility scale power plants are in operation, but many are under construction. Okay, so in terms of power plants, Saudi Arabia has taken some very bold steps. Okay, that is also a part of Vision 2030, and their target is to increase the focus more on renewable energy. Okay, and I think most of you know about it, and not only solar, hydro, and the uh, fuel cell and hydrogen gas. Okay, and different wind, so in different forms. So the target is to reach 130 gigawatt of renewable energy power by the end of 2030. This is the target. But now currently most of the power plants are gas and oil based. So if you look the list, so you'll see either got oil powered or gas powered. Okay, they are mostly, and the biggest one is Shaiba, thermal power plant, which is oil based. This is the largest one currently in Makkah region, which is having around 5.5 K megawatt capacity. Ghazlan power plant is one of the biggest one also, which is gas turbine power plant, which is having this amount of capacity. And this is in Eastern Province. Okay. But there are some top projects currently going on in Saudi Arabia for you to know that these are the top projects in renewable energy. In renewable energy projects, okay, actually, okay, one is in Jove. Okay, this is the name, and this is having 400 megawatt. This is operating currently. In Sakaka, this is also operating 300 megawatt. Okay, Sakaka solar power plant. In Neom city, they are trying to make one, green hydrogen solar PV. So this is solar PV, and also this is, this will use the property of green hydrogen, and this green hydrogen can be converted in to generate the heat, and that can be used to generate the electrical energy. Okay, so this is a big project, and this is in progress. And in the Makkah region, that the same place, Shaiba or Shoiba, I don't know exactly the pronunciation in Makkah. So they are also installing a solar PV project of more than 2000 megawatt capacity. Okay, so these are the running projects going on in Saudi Arabia, just for your knowledge. So we're almost close to the end of the session. um, there are what are the future trends in the power plant engineering? You can understand that, in the future, you can understand that because the amount of fossil fuel, okay, so the amount of fossil fuel, whether this is coal or oil or gas, so the amount is limited. You understand? So, more you use, the reservoir is getting, the reserve is getting low. So you cannot depend upon your reserve of coal or of gas or of your oil. Okay, whatever country you are. So that's why, and also this is also a concern of greenhouse gas emission. Okay, greenhouse gas emission, air pollution. So that's why, in the future world, people are more focusing, the countries are more focusing on renewable energy. And whenever you are using renewable energy, and if it is solar based, you can store that one. So the energy storage solution, this is having lots of research. Okay, and you cannot just depend upon the power plants only. Rather, the better idea is decentralization. So you centralize the power generation among people, okay, among small plants. And this is the idea of microgrid. So maybe another day, if I find suitable opportunity, maybe we'll talk about microgrid and nanogrid and so on. So this microgrid is nothing but decentralization of electrical energy generation and distribution. Okay, and you use the smart grids for this decentralization. Also, you use Internet of Things, you use different artificial intelligence techniques to make it more smarter. Maybe you can, instead of fossil fuel, you can increase the use of nuclear technology more. So there are some advanced nuclear technologies which are under research currently. Okay, so and then if you are using the fossil fuel, you have to be careful about carbon capture and storage. For example, you are uh, emitting greenhouse gas, carbon gases, okay, carbon dioxide, for example. But there are some ways that you can capture this carbon and you can storage this carbon for some better usage. Okay, so this is a field of research also. Okay, and the last one is hydrogen based clean fuel. So this is, we call it fuel cell. Okay, this is a fuel cell. This fuel cell is also one source of energy. If you use the hydrogen atom and you process that in a particular pattern, so you can get the energy out of that. Okay, this is actually the clean fuel and clean fuel or clean energy from hydrogen. Okay, so I think I have covered the things I had in my hand. Okay, and I try to give you uh, a clear picture about whatever type of the power plants we have in the current world, mostly we are using there, as I have already mentioned that, there are some other type of power plants like we have tidal power stations, some are fuel cell based, and so on. Okay, but they are not very popular. Okay, they are not very popular and they're not suitable to be used in all the countries. So, but the ones I have showed over here, if I go back and just go through, mainly the mostly used one is the thermal power plant. Okay, and thermal or steam power plant, which are mainly run by the fossil fuels, gas, oil, or coal. Okay, another way of using them are actually using the nuclear reaction or the nuclear fission. The same idea, but the way of generating the heat is different. This is more, environment friendly, but it has risk, okay, of usage. So I explained in detail. Then hydroelectric power plant. This is a very good option, very much environment friendly, no greenhouse gas emission. It just uses the kinetic energy of water, but you need to have a specific structure. You need to have a river, a big reservoir of water, and you have to construct the dam and so on. Okay, so it needs to be in a particular region of a country. For example, in my country, a particular place is there where we have river and hill. Hill means, the hilly region or the mountains in the same part of my country. Okay, the name of that part is Chittagong. Okay, so a part of Chittagong is Kaptai, where we have this hydroelectric power plant. Okay, so I have shown you the picture of China, and then the solar power system. This is a very clean energy, and like we are we are trying to use more solar energy nowadays, but you can use it in two different ways. One is the direct solar cell usage to convert into DC. Another one is to use the solar energy to get the heat from here and to convert it into thermal energy. And there are thermal power plants. Then I talked about the wind power plant, another renewable energy resource. It can be onshore and offshore. And the last one is the biomass, which is also better than the fossil fuel burning, but it has the same property like we have the thermal power plant. So thank you very much for your presence and for your patience. Okay, so I will make the floor open now for the audience. By the way, I have put the time. It suddenly came into my mind that I have put the time up to 3 p.m. So it's almost 3. Let me make it half an hour or 1 hour. It needs to send update, whatever, no problem. But I just increase the time, okay, so that we don't get disconnected. So thank you very much. So questions, please. I know that most of uh, okay. Most welcome, Dr. Zainab. And my dear students, I know all of you know Zainab, Ahud, and Ahlam, Munif, Shok, Laila, Rehab, okay, Muhammad Hussein. Thank you very much, Tahir. So, if you have any question, yes, ask me question. Yes, Dr. Zainab. Do we use biomass as a source of energy in KSA? Yes, as far I saw, but in very low scale. Okay, not in larger scale. So very low scale. But most of the power plants, I can show you. I can show you. I keep this one open in front of your eyes. You see, this is the power plants in Saudi Arabia, which are actually contributing in the national grid. Okay, so just have a look. 89 utility scale power plant. This is the total capacity. Look at them. Okay, gas, oil, gas, solar, oil, gas, solar. So either oil or gas, even not coal. Okay, some are solar, but look at the the unit of solar are also very small. Okay, But as I have also already mentioned that the big projects are under construction in Saudi Arabia. You see the solar which are under operation. But I think this list is not very updated. I'm not exactly sure which, but this is the place where you can get the information for any country. Okay, any country, biomass, coal, any type. So this is database.earth. Okay, so but as far I know, there are some biomass, but in very low scale. Okay, not contributing uh, in the national grid. Okay, my pleasure, Shok. Okay, that you enjoyed the time. Most welcome. Questions. Yes, I can conduct session, no problem. Also, our other colleagues will conduct some sessions. Okay, but from your end, from the student side, if you have any specific topic that you want to listen from us, okay, so you are free to write that to the chairman, okay, to us, that we want a session on this particular topic. uh, we'll be more than happy to conduct a session. Okay, no problem. So any question from anyone?
Victor, may I ask a question?
Yes, sure. Go ahead.
I've noticed that we don't have as much as nuclear power plant as like Europe or other countries. So what could be the reason?
Well, as as I have already said, that the nuclear power plant, before you establish a nuclear power plant, there are some power plants, nuclear, wind. This type of power plant needs at least several years of planning phase before you go for the establishment. You understand that where you want to do it, what is the way of disposal of radioactive material, and also it needs to be approved by some international bodies. You cannot just install a nuclear power plant anywhere, because any accident in the fusion or the fission process which happens in the nuclear reactor can cause a very severe damage. Okay, so I'm very sure that nuclear power plants can be also, they are much better in terms of environmental impact than the fossil fuels. So uh, the the countries who are not still not using the nuclear power plant, maybe they are planning for that, and if this is suitable for them. Okay, so I'm not exactly sure under construction or under preparation is there any power plant in Saudi Arabia or not. But as far I saw, I have also seen 5 or 6 list of the power plants which are under construction and in Saudi Arabia, either they are solar or wind. Okay, or in NEOM there are some fuel cells also, but I haven't seen the nuclear power plant. So they require some protocols actually. Okay, and many countries, they are proceeding to that. Okay, they are using the nuclear reactor. But I hope that nowadays everyone, all the countries are trying to put they're trying to decrease their dependency from the fossil fuels. This is the main idea, whether they're going to biomass or solar or wind or nuclear. But nuclear is something which is very dangerous to handle. Okay, so that's why it is actually the decision of the country, the policy making, and many aspects. So this is kind of a discussion. So thank you for your question, and feel free to ask. Yes, someone has raised the hand. Please go ahead. We have Dr. Yusuf also with us. How are you, Dr. Yusuf? Say something to us, to your students. Okay, Yusuf maybe is okay. So anyone with any question, please? No question. Okay, so thank you very much. If this oh, I think this has been already recorded.
Dr. Shaib, you wanted me to say something as if you mentioned my name?
Yes, doctor. I was asking for questions. No one was asking any questions. So I said, if you have anything to add, doctor, or any comment.
Well, I think you've done a very good job in explaining the things. Maybe the comment I'll just make to them is because there are a series of presentations that will happen.
Yeah.
Somehow, even though we've not done it that way, but somehow if they put their mind, they should put at the back of their mind that all these topics, you can link them together somehow. You can link them together. For example, if let's say we are discussing something about control and the power systems. The power systems go with a lot of that control in the background.
Exactly.
And a lot of the other things, the different topics. So at the end of it, they need to sit down and have a big picture of like synthesizing everything together in their brain and understand how the things fit together. I think this is the comment I want to just make. Other than that, I think everything was very good. Thank you very much.
Thank you, doctor. Thank you for the comment. Yeah, I totally agree with you. And yeah, because this also I say to my students that when we are studying the electrical engineering, different courses, actually we get the idea of different things. But when at the time of your graduation, you need to link the courses, link your ideas and knowledge together to understand a bigger picture. As Dr. Yusuf has said, to link them together to have the complete picture, because all the courses, or most of the courses, are somehow linked with each other. We use the idea of one in another. For example, this power plant engineering, if you go in deep of it, so you will understand that lots are happening. Okay, when we talked about the solar power plant, if you go in deep of it, actually the idea of your electronics course are there. If you think about the power system, the idea of your circuit courses are there, and control is everywhere, and the communication channel is also everywhere. So actually the courses together should build your basic very clear, and it should build you as a better graduate. But particularly why I have selected this topic, I have already mentioned in the beginning that as far my understanding, this is one of the big knowledge gap in my eyes of our graduates, that they are graduating without the knowledge of the power plants. So this somehow we haven't put this topic in any of the courses. Like it could be maybe as an elective course also, no problem. But as far I understood that this should be known by all the students, all the electrical engineering students. That will make the idea more clearer. Yes, someone has raised the hand. Please go ahead if you have any question.
Doctor, we have taken some of these power plants on solar renewable energy material. So Dr. Yahya explained.
Okay.
Yes. So most of the power plants, we studied it, like how it function and everything on solar energy, renewable energy material.
Okay, so in renewable energy, I think you covered solar and wind, and what else?
And
geothermal.
Geothermal and
this is steam power plants, I don't think, maybe.
Yes, the steam
as well, hydro.
Okay, hydro. Okay, good. That is fine. But I didn't taught that course, so that's why I don't have much idea. However, this is good, but still this is an elective course. So sometimes some of the students go through without taking this course. Okay, but I hope that this for everyone, whoever had that course, I'm sure that you took that course, but maybe from my lecture you got some different ideas, or okay, maybe some ideas which you maybe shaded a bit. Okay. So thank you for anything, any question.
Doctor, do you request the video because I'm coming late?
Sorry, can you repeat?
I'm coming late. Do you request the presentation?
For the attendance, you mean? I'm not sure whether there is attendance or no. No problem. Like I will.
I want to, yeah, I want to repeat the presentation or see it again because I.
Okay. Okay,
Yeah.
no problem. I will share the slide with you. And also, as because this has been recorded, maybe if I can upload it somewhere and share the recording with you. Okay. So that's it. Thank you very much. I think we can stop the session. And thank you for your presence and your patience. And inshallah, we'll see you in another session. Take care, everyone. Thank you very much.
Allah bless you. So thank you very much.
Welcome.